The goal of this course is your success in supporting the VAXStation 3100 series. After you complete the IVUS and lab exercises, you will be able to identify the components, verify their proper operation, and service any failing system. The course menu choices are based upon 3 video segments. Each answers one overall question. The menu has a running time of each video segment. Feel free to view them in any order or any number of times. The screens following this introduction provide information about IVUS functionality that can assist you. This information is also repeated in the course guide. If you feel comfortable with the instructions, press Help and select the menu choice to begin. We hope you find VAXStation 3100 operations and servicing informative and enjoyable. We start here. A busless system, the single KA42 system module contains the CVAX Central Processing Unit chipset, which provides 2.5 times the performance of a Microvax 2. A floating point accelerator for arithmetic operations. High-resolution monochrome video with advanced graphics circuitry includes a dual-port video RAM that holds up to 2,000 line images. 33 kilobytes of total cache memory to improve system throughput and performance. Serial line drivers, receivers, and protection circuits. Time of year clock with battery backup. Built-in Ethernet logic circuitry, which includes the thin wire transceiver. Removable base system ROMs contain firmware for boot and console codes, power-up and extended diagnostics, system exercisers, and utilities. Also removable is the Ethernet address ROM, which should be inserted on any replacement KA42 when the system is attached to a local area VAX cluster. 4 megabytes of parity-controlled RAM are resident on all VAXStation 3100s. You can increase this memory with additional modules up to a system maximum of 32 megabytes. Add the 8-plane color graphics video option to display up to 256 colors or grayscales from a palette of over 16 million hues. The H7821 power supply is a single FRU housing 2 speed control fans and 2 fuses, neither of which are field replaceable. A front mount LED indicates DC voltages are within specification. This basic configuration, known as the Model 30, must operate as a client node connected via Ethernet to a disk server. But you can upgrade this diskless system into a standalone workstation by adding either of 2 mass storage controllers and a variety of storage devices. A new term, SCSI, an acronym for SCSI, or Small Computer System Interconnect, offers improved disk control. This controller supports the newer SCSI mass storage devices and has the capability of driving ST506 devices. The other controller supports only SCSI devices. Available storage devices include a TZ30 streaming tape capable of reading and writing TK50 cartridges and up to 2 RZ23 hard disks, each with a capacity of 105 megabytes. A different version of the VAXStation 3100, the Model 40, acts as a disk server to other 3100s, or as a standalone workstation with optimum storage, and has these differences. The Model 40 comes in a taller enclosure for more internal storage. The Model 40's larger power supply, H7822, has more current-producing capacity to handle the additional storage devices. The mass storage controller in this system is solely SCSI. This system may contain an RRD40 compact disk drive. The compact disk holds up to 600 megabytes of data and is used for loading and running VMS. A top drive panel holds up to 3 RZ23s for a total of 315 megabytes of additional mass storage. Also on this panel, the RRD40 controller attaches by cable to the compact disk drive. If an RRD40 should fail, the controller and the disk drive are replaced as a single unit. Both VAXStation power supplies feature auto voltage select of 120 or 240 volts and are protected with 2 metal oxide varistors from undervoltages, AC surges, and transients. A switched AC output is available exclusively to power the workstation monitor. 8 diagnostic LEDs display troubleshooting information when a monitor is not functioning. A data terminal enabled switch on the Model 40, when up, allows a console video terminal to be used from the printer's serial line port. Asynchronous serial ports are used for a call-out-only communications line, system printer, video connection, mouse or tablet, and keyboard. The halt switch puts the system into console mode for communication with the firmware. All VAXStation 3100s have both a BNC thin wire and a 15-pin thick wire Ethernet port. A select switch enables either one. An LED confirms the active port. Standard on any 3100 with mass storage is a 68-pin SCSI port that allows a variety of storage expansion boxes. Up to 5 expansion boxes can be daisy-chained to the SCSI connector, including a TK50, RZ55, or RRD40 compact disk drive. Video choices include the VR262 and VR290 19-inch monitors, and VR150 and VR160 15-inch monitors. Keyboards include either the LK301 or Gold Key LK302. The VAXStation 3100 series is user installable, from cabling to loading system software. Engineered as an increased performance single-user desktop workstation fully compatible with VMS, Ultrix 32, and their windowing applications. These desktop VAX systems have virtual memory management with multitasking capabilities. These systems can stand alone as powerful individual workstations or be clustered together to provide distributed processing in educational, technical, professional, and commercial offices. A VAX on a desktop, the VAXStation 3100 series. Now, complete the summary on the VAXStation 3100 in the course guide, and then proceed to the other 2 menu questions. You must view all segments prior to selecting the course test. All VAXStation 3100s have extensive onboard ROM-based diagnostics that at power-up, load into main memory and execute. You do not need to load any diagnostic media to determine a failing module. The power-up diagnostics count down as each test completes. First displayed is the CPU name and base system ROM version. Next, each hexadecimal value represents a mnemonic for the circuitry tested. F mono for monochrome base video. Time of year clock. Non-volatile RAM. Serial line controller. Total system memory. Memory management. Floating point. Interval timer. On the Model 40's mass storage controller, SCSI Bus A interface logic, SCSI Bus B interface logic, Ethernet ID-ROM and interrupt control logic, optional 8-plane color graphics module. The next two values are reserved for future options. Lastly, the Ethernet circuits. Each hexadecimal value is followed by a code. 3 periods indicate a successful pass. Other codes include a question mark, which always indicates a fatal error. An underscore indicates the option's not installed. An asterisk indicates an option's diagnostic ROM code is corrupt. The option must be replaced. If the power-up test finds an error, more information is provided for that device. Fatal errors are confirmed with a double question mark. In this case, the monochrome circuitry has failed. The KA42 system module must be replaced. Soft errors are flagged with a single question mark. Soft errors do not appear in the power-up countdown. Many soft errors are more likely to occur when a system is first installed. For example, the time of year clock has not been set by the operating system software. The battery is low. This condition changes shortly after power-up. The battery fully recharges in 17 hours. A monochrome monitor is attached to a system with a color graphics option. Terminate the red and blue connectors. One double question mark that is not a fatal error is caused by an absence of a loopback signal on the enabled Ethernet port. To fix this, either terminate the enabled port on standalone systems or properly connect to the local area network. Other diagnostic information is available from 2 different LED sources. The first source, the keyboard LEDs, indicate these failures. KA42 system module, color graphics option, system Ethernet circuits. The second source, should communications to the monitor fail, is 8 LEDs in the rear of the system. These codes are defined in the VAXStation 3100 maintenance guide. For most troubleshooting, the power-up tests reliably pinpoint fatal errors. If necessary, more detailed information is available in console mode. Console mode is entered with the halt switch and is indicated with this prompt. Enter test 50 to redisplay the power-up results in a configuration table. Also displayed with the CPU name and ROM version is the system's Ethernet address. The configuration table lists each device along with its status and error codes. As with the power-up display, double question marks confirm fatal errors. Single question marks indicate soft errors about the device. Each line is divided into 3 fields: the device mnemonic, status, for example, Mem shows the total system memory in hexadecimal, 10 for 16 megabytes. Error information is to the right of the decimal point. A passing code is 0001. Any other code for monochrome, DZ, memory management, floating point, interval timer, or system devices means a fatal error, and the KA42 must be replaced. The clock, non-volatile RAM, memory, SCSI A, SCSI B, 8-plane graphics, and Ethernet interface may have other codes and still operate normally. Consult the VAXStation 3100 Maintenance Guide. Single or consecutive tests can be run by entering T and the values for the test or tests. More extensive tests are available with the Field Service Exerciser, which requires loopback connectors and keyed media. To run the exerciser, enter T101. The results of the exerciser differ from those in the configuration table. Not all devices are listed or exercised. A less extensive user mode exerciser can be run without loopbacks. Enter T0. See the maintenance guide for more information on diagnostics and system utilities. Now, complete the verification exercises in the course guide before selecting another video segment. You must view all video segments prior to selecting the course test. This segment describes how to service a VAXStation 3100 Model 40. It details replacing the KA42 through rebooting the operating system. Before powering off an expanded VAXStation 3100 that's acting as a disk server to other systems, have the system manager perform an orderly shutdown of the entire cluster. Because the VAXStation 3100 utilizes CMOS technology, the system is sensitive to electrostatic discharge. Always prepare a static-free environment. A service design feature is that the I/O cables can be left attached for most device replacements. However, in this case, the KA42 is being replaced, so disconnect everything and unplug the system prior to servicing. Only 2 Phillips screws hold the cover. Disconnect the SCSI control cable, lift the controller from its standoffs, and let it hang over the back of the system. Disconnect the data cable from RZ0. Disconnect the SCSI B cable from the pop-out on the mass storage controller. Disconnect the front power supply cable to the 3 RZ23s. The top drive panel is secured with 5 captive screws. Including 1 in the access hole. Loosen these and remove the entire drive assembly. To replace any drive, remove 4 screws from under the drive. For any RZ, try to preserve the user's data. Always replace and test the controller before replacing the hard disk assembly. Disconnect the rear power supply cable. The lower panel has 4 captive and 3 Phillips screws. Loosen these and slide the panel forward. disconnect the KA42 interface cable. Set the RRD40 controller on the compact disk drive. If the RRD40 subsystem fails, replace the controller and the compact disk drive as a single unit. Remove the entire lower drive panel. At this point, the power supply can be removed. The color graphics module rests on 4 standoffs and connects with 2 50-pin connectors. Base system ROM upgrades can now be made. Memory options connect in the same way as the color graphics module. Disconnect the battery and system power. This action clears the NVR. Eight Phillips screws hold the KA42. To preserve the physical Ethernet address of this or any VAXStation 3100, always remove and insert the ID-ROM on the replacement KA42. At this point, before reassembling the entire system, secure the KA42. Reconnect the I/O cables and run the power-up test to verify your corrective action. During reassembly, when replacing the KA42, rear screw access might be tight. Ensure that the drive plates align properly. Confirm that the reassembled system passes its power-up tests. A status message for the time of year clock is expected. Select a keyboard language. Reset the NVR to the boot device. Boot the system. Set the time of year clock. Congratulations! You've just performed total service on a VAXStation 3100 Model 40. Service the SCSI expansion devices, RZ55 and RRD40, separately. The RZ55 has 5 FRUs. Load module, hard disk assembly, controller module, power supply, SCSI ID switchboard. The entire RRD40 expansion box is 1 FRU. See the maintenance guide for additional information on servicing the VAXStation 3100. If you viewed all 3 video segments, complete the course test, fill out the student opinion form, and then proceed to the hardware lab. The lab may have a different version of the VAXStation 3100 than is shown in this video. Your lab exercise is to remove and then replace the KA42 system module. Feel free to also remove the power supply or any disk drive. Complete the course by verifying normal operations so the next person to perform the exercise has a working system.